All right, good day, everyone. Today we're going to be talking about 11-3, which is polynomial inequalities. So up to this point, basically what we have been doing is finding our x-intercepts, working that out, trying to get to our final portion, and trying to get to our final sketch of a graph, right? Well, in today's lesson, we're going to be talking about the same concept, but dealing with inequalities, okay? How can we do this? How can we kind of apply this? And then overall, how can we set a specific answer to an inequality of a polynomial? One of the key things I want you to understand is that a lot of times for these polynomial functions, or I should say all the time, our focus is not necessarily a specific location, but usually just because of dealing with factoring, we want to try to figure out when is the value going to be less or greater than zero, okay? Or in other words, equal to it. When you're thinking about these values, when you're trying to think about how would you actually solve this out, one of the key things you want to understand is that all of our coordinates can guide us into finding an inequality of this value. Excuse me. For example, when I look at this problem here, okay, this example, notice how they start this problem. You have x cubed plus 2x squared is greater than or equal to 3x. Well, naturally, to solve this out, you have to move the 3x over. That's how we factor it out. Technically, we can't factor it based off where it's at. So I would subtract the 3x over, and I would get to this position. Ooh, let me grab my marker. This position right here, which is a tendency of what we're going to be seeing. So the idea of this is that we have to try to figure out when that specific equation is greater than or equal to zero. Well, one of the things I want you to understand is that when we go through these problems, as long as you understand where the graph is at, your end behavior, and ultimately where your x-intercepts are at, you can always determine the intervals at which it's going to be increasing, decreasing, and so forth. What that means basically is if I showed you this graph, I know we're jumping kind of to the end, but I just kind of want you to understand the graph itself. We have x-intercepts at these three locations. Well, the thing you want to understand about an x-intercept is that at each of those locations, to have an x-intercept, you have to cross the x-axis. And if we're trying to assume that this coordinate or the axis is where zero's at, everything in the positive is greater than zero, okay? X would be greater than zero. Everything below it is x would be less than zero, correct? So I can use my x-intercepts to my advantage. For example, everything below that x-intercept and everything in between these two x-intercepts are considered to be less than zero. Well, everything above those x-intercepts are considered to be positive, right? So if I'm comparing this idea of when is this equation greater than zero, really all I have to do is focus on where those intercepts are at, because the definition of an intercept is that I either have to touch or cross the x-axis. That's what gives me the zero there in the first place. So by focusing on those, I can come up with a solution for this problem. Now, when we actually go through these, if I was going to solve this out without a calculator, one of the easiest ways we could do this is just following our rules, finding our intercepts, working through it, and then using our end behavior to our advantage. So let's go ahead and look at one of these. Let's just say I did letter C here. Okay, letter C is kind of a good one because I don't want to do a quadratic. I want to do something that's a little bit different for us, okay? So let's go ahead and talk about letter C. Let's just say we were given this equation, x cubed minus x squared is greater than 4x minus 4. And we have to find the intervals in which this works. Well, in actuality, we want to simplify this to actually get to this point. X cubed minus x squared, subtract the 4x over and add the 4. So then I'm really given this equation here. So I want to know when this polynomial here is greater than zero. Well, to do this, I need to understand a couple of things. First off, my leading coefficient is positive. Okay. My end behavior, because it is an odd degree polynomial, okay, we have a 3 as our largest exponent. So that means we know we're going to have opposite end behavior. And since leading coefficient is positive, that means we're going to end in the positive region. So that means I should go from the left should be negative, and the right should be positive, all right? Because it's opposite signs. Let me get that negative sign there. And on top of it, because it is a positive leading coefficient, at the end of this problem, I should end with a positive answer, okay? Last but not least, we know the degree is 3. So I'm going to have 3 total zeros. Okay. From there, I'm going to go ahead and work this out. We go through. To simplify this problem, we're going to work this out and we're going to start our factoring. Well, because it is a 4-term polynomial with a cubed, I'm going to group and start pulling out common factors. Well, x cubed and x squared both have an x squared in common, leaving me with x minus 1. Negative 4x plus 4 both have a 4 in common, but I want to pull out that negative with it to give me x minus 1. That will leave you with x squared minus 1 and x minus 1. Okay. From there, we simplify this. This becomes x squared minus 1 equals 0, and x minus 1 equals 0. Add the 1 over to get x equals, or x squared equals 1. X equals 1 as well over here. So we already have our first 0. To get rid of a squared, we take the square root. If I take the square root of 1, that's going to leave me with positive and negative 1 as answers. So my zeros for this problem are 1, negative 1, and 1. So based off of that information, I can determine that this function has to be x plus 1 squared, x minus 1. Oh, excuse me, flip that. My fault, because it's positive 1, we want to write it negative within the 0. X minus 1 squared. Don't know what's going on there. X minus 1 squared times x plus 1. Okay, so the last key piece of information we want to know is that we have a double root at that location. So let's go ahead and finish this problem up. Let's actually take all this information, apply it, and see how we do. Okay. Well, starting off, if I draw my graph, we have 2 zeros in this problem. Even though it's a degree 3 polynomial, we know one of them is a double root. So at negative 1 and 1, we know the end behavior is going to start going down and end going up. So we have opposite end behavior with a positive leading coefficient. And at the only thing we have to, or the last thing we have to really think about is that at 1, we're going to have a double root, which means we don't cross, we touch. So if I just follow my lines, I should be going through this, touching at that coordinate, and finishing through. Now, we can actually apply this, or we can actually try to think of the intervals at which this is a true statement. Well, I want to know the intervals at which this function is greater than 0, right? I want to know when x cubed minus x squared minus 4x plus 4 is greater than 0. Well, if I assess that, it's going to be from this point to here. So from negative 1 to 1, and from 1 to infinity, because it continues on after that. At all those locations, or anywhere I have a red line currently, those are all positive values, right? Or greater than 0. So I have a union of negative 1 to 1, as well as 1 to infinity. In all honesty, you could even write this as negative 1 to infinity, just like so. Okay? Besides that, that's kind of how these problems work. It's really just following our same exact rules, but now we're just analyzing the graph. Where is it positive? Where is it negative? Where can I compare this to? And then at what interval is this working till? Okay? Go ahead and answer any of the questions within the Ed puzzle. And besides that, you have a great day.